Hello, so in this video, I'm going to talk about our assignment two's Netflix mobile app review analysis. Netflix has been facing subscriber loss and increased churn, and one key hypothesis is that the mobile app experience is a major driver of customer dissatisfaction. And when users encounter streaming errors, account issues, or billing friction, they are significantly more likely to uninstall the app and cancel their subscription. And so, my goal is to investigate this hypothesis using real user reviews, identify the specific pain points driving dissatisfaction, and build a predictive model that can help Netflix product team prioritize the fixes. So I start with translating this business problem into a supervised classification task. Given a task of a user review, can we predict whether it is negative, neutral, or positive? So we define the negative as 1 to 2 stars, neutral as 3 stars, and positive as 4 to 5 stars. And a model that can reliably classify incoming reviews allows Netflix to automatically triage the dissatisfied users and route complaints to the right product teams. So first, we use 5,000 Netflix mobile apps reviews from Hugging Face, sourced from Google Play and App Store. And after filtering to English reviews, removing duplicates, and dropping very short reviews, we are left with finally 1,505 cleaning reviews. And the dataset has a strong bimodal distribution of 55%, which is negative, and 37% positive, and only 8% neutral. And this class imbalance is a known limitation of App Store data, where only strongly motivated users tend to write reviews. And another limitation is that the language field is not fully reliable because some reviews labeled English are actually non-English, and though this has minimal impact on our result. So moving on to the data cleaning and NLP preprocessing. So for general cleaning, we remove the duplicates and then filter the non-English reviews and drop the reviews under 3 words. And for task preprocessing, we lowercased all the text and removed the URLs, punctuation, and digits, and then tokenized, removed stop words, keeping negation words like not and never, which are critical for sentiment, and finally limitized all tokens. And we applied the Vader to the raw unprocessed text, since Vader is designed to work with natural language, including punctuation and capitalization. And our exploratory data analysis reviews several key patterns. So first, the negative reviews are nearly twice as long as the positive ones. So 14.5 words on average versus 8, suggesting dissatisfied users invest more efforts describing specific complaints. And second, the most frequent term in the negative reviews include not, can't, account, and money, while positive reviews cluster around love, great, and amazing. Um, and the bigram analysis pinpoints the exact pain points like can't watch, not working, and streaming service. And those are the top negative bigrams and directly mapping to app reliability issues. And our Vader compound score also correlate with star rating at R equals to 0.58, validating that the review text carries meaningful sentiment signals. And moving on to feature engineering and modeling, and we constructed 3 categories of features. So TF-IDF unigram and bigrams capturing terms importance. Vadar sentiment score as lexicon-based signals and structural features like review lengths and punctuation counts. And we also compare the 4 models using the five-fold cross validation with the macro F1 as our primary metric. And the logistic regression performed best was the CV macro F1 of 0.59, and the hyperparameter tuning with the grid search CV found EC equals to 0.5 as optimal, and improving test macro F1 to 0.55. And we also test the SMOT oversampling to address the neutral class imbalance, but it did not improve the results in this case, as the synthetic interpolation in TD-IDF space is less effective when class overlap is driven by semantic ambiguity rather than data scarcity. And our binary classifier has negative versus positive only achieved the macro F1 of 0.82, which is the recommended approach for the deployment. And moving on to our model evaluation, the best three-class model achieves, let me see. It achieves, 71% accuracy and 0.52 macro F1 on the held-out test set. And the negative and positive classes are well classified with F1 score of 0.78 and 0.74 respectively. And the neutral class remains very difficult. F1 of just 0.05 due to three factors. So first is severe class imbalance as only 8% of the data, and semantic ambiguity where three-star reviews contain both positive and negative language, and boundary overlapping with two-star reviews, and the learning curve confirms high variance with a training validation gap of 0.28, which we partially addressed through stronger regularization. So finally, moving on to our business insights and recommendation. So our analysis leads to four clear recommendations. First, streaming reliability and app stability must be the top engineering priority. Those can't watch and not working are the most actionable signals. And second, the account and login UX needs simplification as accounts related terms appear in over 15% of one-star reviews. And third, the pricing communication should be clearer as subscription value is a recurring complaint. And fourth, we recommended deploying the binary classifier as an automated review triage system with over 55% of reviews being active. Real-time routing of complaints to product teams can significantly accelerate response time and reduce the churn. And that's the end of our presentation. Thank you for listening.